Quad Mode LED Driver by ON Semiconductor. Welcome to the training module on Quad Mode LED Driver. This training module introduces LED driver basics, CAT3604V overview, basic operation, and application circuit. When trying to adopt LED drivers for LED lighting applications, there are a number of issues that arise. As we all know, LEDs are nonlinear, which means the forward voltage varies with current temperature and it varies from part to part. The color point also shifts with current and temperature. LEDs have to operate within their specifications for reliable operation. The figure illustrates the typical LED forward voltage versus forward current profile. For a given temperature, a small change in forward voltage produces a disproportionately large change in forward current. As LEDs heat up, the forward voltage drops and the current passing through the LED increases. The increased current generates additional heating of the junction. If nothing limits the current, the junction will fail due to the heat. Therefore, constant current drivers are generally recommended for powering LED light sources. LEDs are a current-driven device that require current limiting when driven from a voltage source. Therefore, the primary function of an LED driver is to limit the current regardless of an input condition and forward voltage variation across a range of operating conditions. However, the constant current not required to be a DC level, as human vision filters out current ripple if the switching frequency is above 100 to 150 Hz. The end products need to meet two different performance objectives, like parametric requirements, efficiency, current tolerance, cost, and safety. The CAT3604V is a high-efficiency quad-mode fractional charge pump that can drive up to 4 LEDs with input supply voltages as low as 2.5 volts. An external RSET resistor is used to control the LED channel brightness, while channel diagnostics include automatic detection for both short and open LED channel solutions, ensuring the CAT3604V maintains the highest efficiency level in all operating modes. Each operating mode uses a constant high-frequency switching scheme, which allows the use of small form factors external ceramic capacitors while delivering excellent low-noise input supply ripple up to 5.5 volts. The EN input control supports direct pulse width modulation dimming and can accommodate dimming frequencies in excess of 10 kHz, thereby providing extremely high resolution brightness levels. The device is available in the 16-path low profile, 0.8 mm thin QFN packaging. This slide shows the functional block diagram of the CAT3604V. The device is integrated quad-mode charge pump, which delivers the high efficiency levels normally associated with inductor-based LED drivers, while eliminating the associated high-profile inductors and unwanted EMI. The 4-channel charge pump has a pulse width modulating dimming interface and channel diagnostics, which include automatic detection for both short and open LED channel conditions to ensure the device maintains the highest efficiency level in all operating modes. At power up, the CAT3604V starts operating in one mode, where the output will be approximately equal to the input supply voltage. If the output voltage is sufficient to regulate all LED currents, the device remains in one mode. If the input voltage is insufficient or falls to a level where the regulated currents cannot be maintained, the device automatically switches to 1.33 mode. In 1.33 mode, the output voltage is approximately equal to 1.33 times the input supply voltage. This sequence repeats in the 1.33 and 1.5 mode until the driver enters the 2 mode. In 1.5 mode, the output voltage is approximately equal to 1.5 times the input supply voltage, while in 2 mode, the output is approximately equal to 2 times the input supply voltage. If the device detects a sufficient input voltage is present to drive all LED currents in one mode, it will change automatically back to one mode. The LED current is set to by the external resistor. The EN pin enables and disables the device. The LED driver enters a zero current shutdown mode if EN is held low for 1.5 milliseconds or more. As soon as the EN pin goes low, all LED channels are instantly disabled, where the LED current is set to 0. As long as the CAT3604V is not in shutdown mode, the LEDs turn on as soon as the EN goes high. For applications not requiring all channels, it is recommended to connect the unused LED pins directly to Vout. The figure shows the application with 3 LEDs. If an LED is disconnected, the device senses that, runs the diagnostics, then ignores that channel and goes back to the most effective mode. When all LEDs are disconnected, the device runs diagnostics and goes to one mode, where the output is basically equal to the input voltage. As soon as the output exceeds about 6 volts, the driver resets itself and reevaluates the mode. The EN pin is used to provide total shutdown of the device as well as high-resolution pulse-width modulation dimming control on the LED channels. Shutdown of the device occurs after the EN pin has been held low for 1.5 milliseconds. During the soft start power-up sequence from the shutdown mode, the LED current typically settles within 40 microseconds for one mode operation. This LED current settling time becomes 400 microseconds if 1.33 mode is needed. For high-resolution pulse-width modulation dimming control, the device will remain powered and only the LED channels outputs will be switched on and off during the pulse-width modulation. This allows the output channels to have instant on response, where the LED current settles within 1 microsecond of the applied pulse-width modulation dimming signals. The driver requires 4 external 1 microfarad ceramic capacitors for decoupling input, output, and for the charge pump. Both capacitors have to be of type X5R and X7R for the LED driver applications. In all charge pump modes, the input current ripple is kept very low by design, and an input bypass capacitor of 1 microfarad is sufficient. LEDs with forward voltages ranging from 1.3 volts to 4.3 volts may be used. Selecting LEDs with lower forward voltage is recommended in order to extend battery life and keep the driver in one mode longer as the battery voltage decreases. In charge pump mode, the driver switches internally at a high frequency. It is recommended to minimize trace length to all 4 capacitors. A ground plane should cover the area under the driver IC as well as the bypass capacitor. Short connection to ground on capacitors C-in and C-out can be implemented with the use of multiple routes. A copper area matching the TQFN exposed pad must be connected to the ground plane underneath. The use of multiple routes improves the package heat dissipation.